1. Okay, so this is the video for Math 117 regarding the linear regression analysis that we did in class. I'm going to go through the same steps that I went through in class to do the linear regression analysis with all the additional steps that will be necessary later on when we add in additional regression functions. So I'm working with the example that we did in class. I've got my calculator here. Let me get that. There we go. Back to the main screen. All right, so I've got the golf ball example sitting up here in the upper corner. Remember, we're swinging a golf club at a ball and measuring the distance, measuring the speed at which the club is moving. That is this column here. And then we're measuring the distance that the ball goes at a particular speed in yards over here. All right, our input is going to be the speed of the club head, and our output is going to be the distance that the ball goes. That means my x is the club head speed, and my y is the distance that the ball goes. That's going to be important when I enter my data into the calculator. So there are 5 basic steps that you're going to have to go through for each of these problems. The first one is to enter your data into the calculator. All right, so what I'm going to do is, hopefully I'm not going to cover up too much of this here. You want to hit the Stat button here to pull up the Stat menu. Then just hit Enter on Edit and you'll see 2 lists. The calculator defaults to L1 being the list for X and L2 being the list for Y. Enter your numbers in, just type a number and hit Enter. You'll see it pop up there. So I'm going to try and do this quickly. All right, let you guys keep up with me there. And hopefully, when I get to the end of this, I have 8 numbers in my list. Yes, I do. All right, so once you've done that, come over here to the right arrow, tab to the right. All right, you'll see it'll move over to list 2 and then put in the numbers for list 2. So do that real quick. And hopefully I line up. Yes, I do. Okay. So if you did this correct, you should have 8 data pairs in the list here. All right. Now, everything we do is going to be on the calculator. There isn't really any by hand work except to just note down the values that we get off the calculator. So before we do anything, we have to exit out of stat mode. So second mode will quit you out to the home screen. If you don't do that, your calculator is going to think that what we do next, we are trying to do in a data cell. So you have to remember to exit out. All right, so the first thing we're going to need to do is to plot the data on an XY axis. All right, so that's going to mean turning on a stat plot. So if you see right above here, right above the y equals, you'll see the word stat plot. So hit second y equals. Now there's a bunch of different stat plots. You just want the first one. So I'm going to go into the first one and I'm going to hit enter over on, and you'll see that turns it on. Everything else should be default at this stage of the game. All right. The default type is a scatter plot. The default X list is L1. The default Y list is L2. All right. So as long as I've got that done, I'm going to exit. I'm going to exit out of that again. All right. All right. Now, in order for my stat plot to work, I have to have the window set properly. So I'm going to go into the window, and I should be at the default -10 to 10 if I haven't done anything else. All right, and I want to look at my data and notice my smallest data value is 99 on the X, and my highest data value on the X is 105. So that's how I want to set my window. All right, I can give myself a couple of points on either side for a little bit of wiggle room if I want to. So maybe I go 97 for my minimum and 107 for my maximum, just to have a little bit of wiggle room in there. All right, don't worry about the slicing. That's not necessary. Okay, so now over here, my lowest Y value is 257. My highest is 275. So I think what I'm going to do is just go from 250 at the low end to, let's say, 280 at the high end. All right, now when I hit graph, what I should see is a nice scatter plot of my data. Now remember, at this stage, you're only working with linear data. So there's nothing you really have to do with this. I just want to get you used to working with it. All right. Once we get into other regression functions, you're going to start seeing other shapes that are not just linear that you're going to have to make decisions about before you go on to the next step. All right. Okay, so we can see what the data looks like. We can see that it's basically linear. All right, so we've taken care of the stat edit and the stat plot. So the next thing we have to do is pick up our correlation coefficient. All right, and I'd also, and I actually forgot to write it here, so let me do it right now. We also need the, all right, no, I guess I'm not. We also need the, what do you call it? Hang on a second. I just realized I turned something off before I grabbed my pen. No, I did grab my pen. Okay, never mind. Oh, there it is. Okay. We need the regression line. So, excuse me, I'm still a little bit sick. All right, so I think we said that was A plus BX, because we're going to need that if we're going to make any predictions about our data. Anyway, all right, so what we need to do now is go into the stat linear regression t-test. So again, exit out to the home screen, always a good idea. Go into stat, move over to test, and I'm just going to use the up arrow because I know the test is at the end. All right, I think on most of your calculator ROMs, you should see lin reg t-test at F. All right, there might be some slight variations in there. All right, so I'm going to hit enter on that. Now, pretty much right now, everything should be set to the defaults. The X list should be L1, the Y list should be L2. Everything else here you can ignore. None of this is important to what we're doing. You just want to hit calculate. And again, I'm going to pull out two things from here. All right, notice over here, A and B. All right, so A is my y-intercept, B is my slope. All right, so if I come back over here now, I can, I'm just going to put a little colon here. Right, my y, I'm going to round this off to one decimal place. So A is negative 55.8 plus 3.2x. All right, so I have my regression line like that. Now you'll also notice at the bottom here, right, as I tab down, you see R equals. All right, R is the correlation coefficient. All right, so R is 0.9386, all of that there. Again, I'm just going to round it off. Actually, I think I'm going to do it to 3 decimal places instead of just 2, and I'll explain why in a minute. In class, I only took 2. All right, so this is going to be 0.939. 939. All right. Now, we were talking about whether something is a strong correlation or not. You would think that 0.939 or 93.9% would be strong, but remember, strong depends on how many data values you've got. All right, so if I have a small data set, 93.9 may not be enough. If I have a large data set, yeah, it's going to be enough. So the way we determine that is with the critical value. Now, the critical value is on page 171 in your textbook. And it's the table you see all the way on the left of the screen, right over here. It's based on n, the number of data values that you've got, all right? And it goes all the way up to 92. Anything more than 92, you can use your intuition for, okay? If you've got anything more than a 0.2 correlation, you're strong. All right, but we have n equals 8. So n equals 8 is right here. All right, so n equals 8 gives me a critical value of 0.707. So my critical value is 0.707. Now here's why I decided to round my R to 3 decimal places this time. It makes a nice, simple comparison. So remember what you want here. If the absolute value, right, let me come down here. If the absolute value of R is greater than your critical value, that means you have a strong correlation. And a strong correlation means you can proceed with whatever process you wanted to do with your regression function. All right, so over here, the absolute value of 0.939 is 0.939. Right, so 0.939 is greater than 0.707. So that means I can check that off. I have a strong correlation there. All right, now, so that means that I have a regression function that I can use to make predictions. And that's the important thing. That's the important thing to get out of this. Now, when we move on to multiple regression functions and we have to make a decision, you can't just base your decision on whether or not you have a strong correlation. You could have 3 different functions, all 3 of which produce a strong correlation. You could have 3 strong correlations, all of which are within, a 5th decimal place of each other. And if we're only looking at 3 decimal places, that means they're all the same. All right, so we have to have a second tier of criteria. And the second tier of the criteria to determine which function we're going to choose is the sum-square residual. All right, so the way we get the sum-square residual is, first of all, we clear the screen here. All right, and if you notice above stat, you'll see the word list. So I'm going to go second list. All right, and if you see here, we've got a list of all the lists. That's exactly what that is. That is a list of all the lists. And down here at the bottom is one last list, number 7, resid. Resid is the list of residuals. All right, so remember, residuals are the difference between a predicted value and an actual data value. All right, using our regression function. So what happens is every time you run a regression analysis, every time you do step 3 on the list here, okay, this resid list gets repopulated with a new set of residuals. So this now has the list of residuals for our function. And in fact, I can show you, I can't show you with the mouse though, can I? I can show you if I go into stat and edit, I can move over to L2 and tell L2 that I want it to be the residual list, and you'll see it populate there. All right, so if you were to take 100 and plug 100 into our regression function here, the difference between the value that I get from this regression function and the value that I get from the data will be approximately negative 3.8. All right, that's what a residual is. All right, so let's get out of this. All right, so to calculate the sum-square residual, we are literally doing the sum of the squares of the residual list. All right, so on the calculator, we need to set up the sum, and that is a function you'll see in a minute. LResid is going to be the name of the list, or ESID. We're going to square it, close it off, and hit enter. All right, so there's list math. If I go into list and over to math, you'll see a bunch of stuff that I can do with the list. I can find the minimum or the maximum. I can find the mean or the median. If you've taken statistics, you know what that is. I can do all sorts of stuff with the lists. All right, what I'm interested in is down here at number 5, the sum. So I'm going to pull that in, and notice that pulls it onto the home screen. Now I have to tell it what list I want to add up. So I've got to go back into list, second list, and I'm going to go down to the bottom there to number 7, and I'm going to pull my residuals list in. So now I'm adding up the residual list, but I want the square, so I'm going to say squared. All right, close your parentheses. That step is actually optional here, and hit enter, and I'm going to pop out a value. All right, so my sum squared residuals ends up being 49.8. I'm just going to say 86. We'll round it off like that. All right, now for right now, that's just a calculation you're going to do. It has no meaning by itself. The sum squares residual is a comparative value. So once we're looking at 2 or 3 or 4 different possible regression functions, we're going to use that value to determine which one we're going to use. And of course, we want the one that minimizes the sum square residual. All right, so this should get you through the homework problems I gave you to do over the break. At the end of the break, I will put up a second video talking about some of the other regression functions that we're going to look at when we get back in class. All right, bye-bye.